Good day, madam. Good day, team. My name is Oloyede Ogunsalu, and for our case study number 3, where we look at the resource allocation solution for the hospital, I was privileged to take up the task of generating the data set needed for the case study. It was quite challenging considering the fact that data set is one of the core parts of the case study. I consulted a lecture slide where I got some knowledge to be sure of the data set needed and the model type that we were working with. Afterwards, I went online, did some research, and viewed some literature works where I was able to get some more knowledge. So I did some subtractions, some additions, and I was able to come up with 2 data sets which I presented to the team. And afterwards, we asked relevant questions, making very good suggestions. And afterwards, I was able to do some adjustment to the data set. And finally, we were able to get a data set. I actually presented 2 data sets to my team with varying ideas in terms of the season and in terms of the forecast, the case study, what we are looking at. And we picked the one that best suits our case study. And we began work with that. So it was more like a query from the past year of the hospital, where we look at from January 1st to the 31st of December, or we look at the patients, and then based on the query of the sugar level and the blood pressure, we were able to go into generating a forecast where we can correlate these 2 health concerns with the number of days that the patients were being admitted into the hospital. So the data set for the hospital also, I was able to generate and get some generic words like the blue ward, the yellow ward, the brown, and the bed capacity for them. The bed capacity, there's a general capacity and the current capacity that they have, and also the sicknesses were in sections where the hospital know how to put infections and malarias and cholera in general like that in different words. So I was able to create all of those, and then we began work on them, and then mapping the staff strength to the patients at hand. I was able to generate that. So I also came up with suggested directions in which the data analysis and the forecast algorithm should go. The concept that will be fine, will suit it. I shared that with the team, the optimization idea and other guidelines. So I redid that with my team so that we can all be in flow and correlate with the case study. And work with my team has been very quite tasky, especially because of the time difference, but we were able to walk through and scale all over that hurdle. And I believe that's one of the lessons to learn when working with a team. I was also able to mobilize the team, organize many of our meetings, and do a lot of checks and finalize the project, create the content outline, structure, suggestions, and input output with my classmates. We were able to get to a point where each one of us have a core area to work with and to get the job done. Yes, and like our madam do say that we should enjoy ourselves in the journey. The journey was quite enjoyable. Yes, irrespective of the challenges of time constraints, the difference with the team. It was quite enjoyable. I enjoyed myself, and I'm glad to be part of the team. Thank you very much, Ma, and thank you, team. Cheers.
Hi, we are from group 15, and then our case study is, which is the number 3, improving hospital resource allocation. My name is Gini Arimbi. I have a non-IT background, and then I would like to explain my parts, which are the background and the literature study. Okay, so started with the background. Um, so starting with the background, in recent years, there are trends that the hospital expenditure is keep increasing from around 27 to 37% accounted for part as the healthcare expenditure growth. And then this is happening in both developed and developing countries. So what happened is that during peak times, hospital resources are quite scarce, such as the number of bed, hospital staff, and equipment. This scarcity will create an issues to the hospital itself. Several things that can happen because of that, which are the imbalance between the patient seat and then resource capacity. Also, um, there will be a lot of bottlenecks so that it has a possibility to increase the mortality rate due to the lack of service that the hospital can provide. And then, actually, hospital resource have a quite unique characteristic. Their equipment cannot be easily replenished. So, for example, like during COVID, there are a lot of scarcity um, on the ventilator, and it's not easy to directly to produce it. That's why. mm this healthcare characteristic is quite unique. And then this project will explore intelligent decision support system to optimize hospital resources allocation. Okay, and then I will go to the literature study. There are several terminologies that are usually being used to describe the efficiency in the hospital setting. So first is the hospital bed. Hospital bed is one of the most important variables because it can tell a lot about the capacity of the hospital. And then we usually calculate the um, service that can be provided by hospital by LOS or length of stay or bed occupancy rate or BOR. And in this case study, we are going to forecast actually what will be the number of bed required for the hospital. And then in here, we will use the profit time series and then XGBoost. So profit time series is one of the procedure for forecasting time series. And then one of the advantage is that is the ease of use in tuning time series method. So it enables people or analysts with limited prior knowledge before. And then it works with seasonal effects and several seasons of historical data. And then the second part is the XGBoost, which is part of the machine learning tools. And it's formulated as a binary classification, and is trained for each relation using relevant links in knowledge graph. Last, we also have the optimization model. There are several methods that can be used to do optimization, such as goal programming, boundary programming, integral linear programming, and weighted optimization method.
All right. My name is Jora Maindize, and I'm going to give a presentation on the objectives of the case study number 3 that we're doing, which is on helping hospitals to be efficient and effective in terms of resource allocation. So I'm going to share my screen so that I share on the objectives. All right. So number one objective of the objectives that we have with regards to the system in terms of how to implement intelligent decision support systems that enhance or that improve hospital resource allocation is enhancing resource utilization. So improving the efficiency of resource usage, that is bed, staff, equipment during peak times, to minimize waste and reduce costs. All right, so this is one of the objectives. that we have, and this will lead to reduction of patient waiting times. We are saying the amount of time that patients have to wait, and improved overall patient care. That means the time and also how they feel cared for due to resource allocation, be it staff and also be it in terms of equipment. Then balance the staff workloads, which will help prevent burnouts and also improving job satisfaction, how employees will be happy, creating a comfortable environment for them. Then provision of actionable insights and recommendations to the hospital administration and staff to facilitate informed decision regarding resource management. So that's on enhancing resource utilization. That's our number one objective. Our second objective is forecasting demand. So through our system and through our flowcharts, we want to be able to develop accurate demand forecasting models to predict patient admissions based on historical data and external factors that we have been researching, that my colleagues also will share. And number three is optimize resource allocation, right? Which is implement optimization algorithms to allocate resources effectively, ensuring that hospital can meet patient needs without overextending its resource. This is something that we also look forward to achieve in terms of our objective to do. Then utilize technology effectively. So we want to leverage modern technologies and data analytics tools to create a robust, intelligent decision support system that is user-friendly and integrates existing hospital systems. So that's also something that we want to do in this system. Number five is continuous improvement. We want to establish a framework for ongoing assessment and refinement of the IDSS based on the user feedback and evolving hospital needs. So in our development or in our prototype, we are going to find out that we have a feedback approach that we continue to cultivate that feedback so that we can continuously improve the system. Then we will come up with a flowchart that will show the IDSS and demonstrate its functionality. Then we're also developing a prototype. We're going to create a simple prototype of the IDSS, which is also going to demonstrate functionality as well in terms of how this IDSS will help hospitals in terms of resource location. Thank you. My colleagues will take it from here and explain further.
Good morning. My name is Olashile. I and my team worked on a group project on a case study that talks about improving resource allocation. Well, the major part, my own case study, is channeled to, has to do with the problem statement, the ethical considerations, and the conclusion. For the problem statement, the major challenges the healthcare system always face is effective resource allocation, and this results to serious reduction of patient quality care, operational cost, and delivery inefficiency. The introduction of an intelligent system which can improve hospital resource allocation by factoring the real-time decision-making, historical data, advanced data analytics, and prediction of resource needs can curb these challenges. Moreover, optimization is considered in this situation in managing inventory, staffing, and appropriate use of medical facility equipment, reducing costs and enhancing patient outcomes. Below are some of the challenges that resource allocation can encounter. Number one is inaccurate demand forecasting. Inadequate hospital equipment to anticipate inflow of patients tends to cause resource to be under or overutilized. Number two is improper management of inventory can result to shortages or wastages of critical medical supply, which affects patient care. Number three is understaffing, can lead to compromising of patient care and overutilization of staffs. Talking about the ethical consideration, we all know ethical consideration play a crucial role in the implementation of IDSS for an hospital resource allocation. Equity, for example, we will ensure that resource allocation decisions are made without bias, providing fair access to care for all patients regardless of their socio-economic status, race, or gender. Transparency, maintain transparency in decision-making processes to build trust among patients and healthcare providers. This includes clear communication about how resources are allocated and the critical use. Data privacy, safeguard patient data to prevent unauthorized access. and ensure compliance with data protection regulations such as General Data Protection Regulation and Health Insurance Profitability and Accountability. Bias mitigation. Regularly review and update algorithms to prevent and correct any bias that may emerge in the system. This brings me to a conclusion. Improving hospital resource allocation through the use of an intelligent decision support system represents a significant advancement in healthcare management. By leveraging data analytics, predictive modeling, hospitals can make more informed decisions that optimize resource utilization, reduce costs, and enhance the quality of patient care. Ethical considerations such as equity, transparency, and data privacy must be meticulously addressed to ensure the successful and fair implementation of such a system. This integration of advanced technology and continuous monitoring and evaluation of the IDSM will be essential in achieving sustainable improvements in hospital resource allocation. Thank you very much.
Hello, you guys. My name is Pong, Kolchit Pong Hur. You could call me Paul, or you could call me Cole if you would like. So since since we have 7 members in our group, everyone sort of like picked everything to do already. So I decided to just help my other 2 team members with the optimization and implementation. So you might have heard it from my other team member first who did the implementation, or you might going to hear it after. Depends on how the video is being edited. But yeah, my other team member, he was the one who did the modeling. So he did machine learning using XGBoost and a time series forecasting called Prophet. Yes. So so he did that for forecasting, which in other words is prediction. But me on the other hand, I used Excel, as you could see here. And then I sort of like, I wrote a little bit on like how we could assign each patients and staffs to all the words, because obviously, as you can see from the earlier section, we have like the word, we have like the data set, the data about the words. So I wrote a little bit on how to like assign patients. Basically, we would like to leave the biggest word, we would like to have like, okay, this is our biggest ward, and then we could have like some rooms reserved in have some like beds, sorry, in that ward reserved for emergency patients, because you know obviously the biggest ward is also going to be the busiest. Yeah, and in this case it's the pink ward because it has the largest capacity. It is also for patients who are predicted to have like a really short admission time. So you know, like since this is the largest ward, we could like assign like a couple staffs in there, and we could have like patients who are not staying as long, just like going in and out, like keep the flow going. And then here's the important part. I did this. It's called Excel Solver, which is what this do is it essentially basically just like allocates the beds and the staffs for you, and this is really good for a small to medium sized hospital. If it's bigger, then we're gonna have to use like Python or like a more dynamic machine learning model. But since our data set is pretty small, so this works really well. So yeah, what we did here is pre-processing the data, and then a little bit and everything, of course, and then in Excel, but basically we want to have like this header, like we want to have this form of a data set. So once we got that, what we essentially did was we went to Excel, and in Excel, go to data solver, and we apply this formula. And then we did this, as you can see here, bit more formula, and then we set the constraints. So these are the constraints. Of course, the allocated beds has to be smaller or equal to the available beds. That's just logic, common sense, and everything. So all the constraints here were set, and then finally we applied the Excel solver function or method thingy, and then it automatically do the allocation for us. That's about it. Thank you.
Good day. My name is Kanan, and I'm a member of Group 15. We have chosen to do case study 3, which is based on improving hospital resource allocation. And the part that I'm assigned to do is to create a flowchart of the decision-making process. And I have done a flowchart first on the proposed forecast. After you start, we would then begin by saying we would start by collecting patient data. This would be the historical data, that is records that are already in the hospital. We need to then do some pre-processing where we are going to clean the data, ensure that the data is valid, eliminate any empty records, and ensure that the data is going to provide us with a clean basis from where to start off. The decision tree occurs where we are going to now select a forecasting model, and we have made a decision on our forecasting model, which we have chosen to do machine learning. We could have gone down linear regression or something else, but we've gone down machine learning. We then go down and have decided we are going to do some training to the model. This is going to ensure that the model itself can actually produce valid data, and we can see whether the model is able to predict accurately after it has done some training on the historical data. After the training has been done, the forecasting model will then be used to generate predictions, where it will then forecast, for example, data about how many beds will be necessary over a flu season, for example. And it is then going to be tasked with providing decision support as to assist with graphical user interfaces that are supposed to assist the decision makers in making valid decisions. I also then proceeded to create a table that gives a detailed breakdown of each step and a reason why we would use each of these steps in the process, which I have tried to summarize as I've gone through. After we were done with the proposed forecast, we then went through the data analysis, which someone else in my group is going to talk about. But then we decided we were going to do a flowchart. We were going to do some testing of the optimization of this IDSS situation. The flowchart that is here is going to start now with an input of forecasted results and not historical data, and even real-time data as it goes. This then is going to have the constraints defined, the constraints being any hospital rules that might speak about one doctor is accountable for 10 patients, etc. And these rules need to be defined. We identify the available beds and the staff. That is what is being done in as we try to optimize the system. Once these have been identified, we determine the forecasted patient load, which is coming from what has been said up here, and we are going to be double checking to see, does what was forecasted meet what has been predicted to be, what is actually required at this point in time. Then we will calculate the required beds and the number of staff that are required. A check is then made where we check, are the resources sufficient? If they are sufficient, we will then allocate the beds and the staff to the department that it requires them. And if they are not, we need to then optimize the solution using a solver. For example, something like Excel would be a good place to start. We then go on to monitoring and adjusting these allocations, because this is a circular motion. We would then need to double check to see, have we actually managed to allocate the beds accurately, and have we managed to optimize the solution properly before we get to a point where we can say we can conclude. I have also provided a table at the end here that gives an in-depth detailed description of each step and a reason for why I have chosen each of these steps in an attempt to show how we are using the optimization which one of my group members is going to speak about again after. Thank you very much, and I hope you have a wonderful day. Bye.
Hello, my name is Ahmed Shahryar Khan. I am a member of Group 15. Our group is based on 7 members. We have divided the task among us. We have selected the case study 33, Improving Hospital Resources Allocation. Mainly, I'm responsible for coding, where prediction, forecasting, visualization of this assignment. In this video, I will briefly explain what I have developed. For more details, if you would like to see the walkthrough, you can run the code we have provided. So if I straight go to data, so in this section, the system reads and processes Excel file containing patients and hospital data, and it's based on our group assumptions rather than the actual hospital data. It skips metadata, set proper headers, reset the index of consistency. Conditional logical is applied to handle various hospital data structure, ensuring clean and structured information by renaming and removing unnecessary columns. If you see as an output, I am showing a simple output of 5 rows, and then it's processing, like a pre-processing. The data pre-processing steps ensure consistency and readiness of analysis. It converts admission and discharge dates to dateset format, ensuring admitted data are in numerics. Extract months and year for feature engineering. Categorically, variables like sickness, sugar level, blood pressure are encoded in numeric values. If you can see, by using label encoders, making the data suitable for machine learning. Then we have data analysis. System usually broadly create interactive visualization, including histograms, bar charts, box plots. It analyzes the distribution of the patient, like length of stay, examines patient counts by ward and sickness, provide time series overview, monthly admission to identify the trends. Then we have this exciting beginning of this model where we are predicting. So it predict patients' length of stay. Models select relevant information from the pre-processed data, split into training and training sets using 80-20 ratio. Then you can see here time series for data each ward. It's actually to analyze trends continuously. Date range is created for earliest admission to the latest discharge. Daily patient counts are calculated for each ward and then merged into a single data set. Finally, the data is visualized to track patient trends over time. And this you can see, and details are also provided. Then, interestingly, the training forecast model using Prophet. So the forecasting, a separate Prophet model is trained for each ward time series, yearly and weekly. Yes, weekly, seasoned enabled. The model are stored for future use, and the data is formatted to meet the requirements for accurate predictions. Resource requirement. So the request requirements to assess resource needs, forecast data is matched with hospital ward information, comparing predicted patient counts with current bed and staff capacity. Additional requirement including a buffer in peak periods are calculated and stored for each support efficiency resource planning. We have visualizing results and resource requirements. It's usually visualize forecast and resource needs. Plotly is used to overlay historical data with prediction, including uncertainty inbounds. Group the bar charts, compare current and beds and staff, while additional resources are highlighted per ward. I can show you in graphs. These interactive visuals provide clear insight to patient trends and resource planning. And these all information are provided in our documentation. You can go through in detail. You can see the numbers. So versus current versus staff required. Here I mentioned, for example, the resource needed additional. Then we have generating summary. So detailed resources plan report is generated for each ward, summarizing summarizing current capacity, forecasted patient load and resource gaps. It also segregates the total additional beds, and staff needed across all wards, presenting the information in clear, readable format for hospital management. Considering the time limitation from this section onwards is mostly reporting. So it indicates, I summarize it. So it indicates that the system automate patient length of stay prediction by storing results, forecast and report in Excel. It saves train model and in encoders for future use, ensuring seamless prediction without retraining. Using LM like a machine learning, it's estimate the stay during for individual patients and generate detailed reports including discharge and estimates. The new data is processed, formatted and integrated into our workflow, allowing each batch predictions for efficiency. Finally, all the data including predictions is saved for clinical decision making, completing end-to-end automation. That's all from my side. Thank you. I hope you appreciated our teamwork on this group assignment. Thank you.